Hey, what's up, guys? It's Dark Shadow, and today I'm back with another coding video. In this video, we're going to be covering how to use HTML Canvas to generate frozen spikes. It's a pretty cool effect if you get it right. So let's begin. So first, I'm going to go to the HTML and put a canvas element, then go to the CSS. So I'm going to say the root selector, the asterisk selector, we're going to put margin 0, padding 0, so that keeps everything like it basically removes browser default margin styles and padding styles. Then we want to go box sizing border box, and then for the canvas, let's just say width 100%, height 100%, background black, and there we go. That's all we needed to do. Then we want to go to script and then say we want to create our canvas setup. So we'll select the canvas with the query selector. Then we'll create a variable called context, and we'll say canvas.getContext, and we want to say 2D. Then canvas.width, we'll set it to inner width, so that covers the entire screen's width. And then the same with the height. So we'll say canvas.height equals inner height. So now the canvas covers the entire screen, and it's a black canvas. So then what we want to do is let's create a variable called mouse, and we'll set it to an object with properties x being null at first and y set to null also. Then what we want to do is create a function called init, and then we'll say we'll put a for loop, and then if I is less than 10, we'll increase I by 1, and then we'll say we have to create an array called particles, and then we'll set it to an empty array. Then we want to go particles.push new particle. So if you're wondering what particle right here is, we're gonna define it later. Then we'll create our animation loop and say ctx.clearRect 0 0 canvas.width canvas.height for 0 so it'll iterate through every single particle. Oopsies, got a little carried away. So it'll iterate through each particle, and each particle it'll draw the particle and then call the update method, which animates it pretty much. Then we'll go request animation frame animate. Oops, don't put the parentheses there. Then we're gonna call animate. So nothing's gonna happen yet because we haven't created any particle class. But before we get to that, let's add an event listener for mouse move, and we'll put ms for mouse as the parameter, and then we do the same with and then we set the x of your mouse to your mouse's x and mouse.y to your mouse's y. And then we'll create a boolean variable called mouse down, and we'll set it to true. No, we want to set it to false. And then we'll create another two event listeners for mouse down and mouse up. So all we're going to do is set mouse down equals true. And we'll do the same thing with mouse up, except mouse down will be set to false. There we go. Then we want to say if mouse down, we want to call init. So that's all great and all, but it won't do anything. We are going to want to create a class for the particle. So class particle, and then we'll say constructor. We don't want any parameters, and then we'll say this.x equals mouse.x, this.y equals mouse.y, this.size equals, we'll say math.round, so we have a whole number, math.random, so it'll generate a random number from 5 to 10. Then we want to say this.delta x is set to math.random times 4 minus 2, so it'll generate a random number between minus 2 and 2. We'll do the same with delta y. So that's literally all we need. So let's create a draw method, and we'll say ctx.beginPath so the circles don't connect, and then we'll say ctx.fillStyle is set to, since we're doing a frozen spike generator, we'll say the fill style is white. Then we want to set the stroke style to this RGBA color value. So 150, 190, 255, 0.5. So it'll create a frozen Arctic ice effect. Then we want to say arc, this.x, this.y, this.size, 0, and then pi times 2. That'll create a circle at the correct coordinates with the radius being this.size, the particle size. Then we want to say ctx.fill and then ctx.stroke. Then let's create an update method, and we'll say this.x is increased by the delta x of the particle. Then the same with this.y. We'll set it to the particle's delta y. Then if this dot size is greater than 0, we want to go this dot size decreases by 0.25. So There we go. We have this effect, but the problem is it doesn't generate spikes. So there's a simple fix for that. It just creates snowballs. It's also a cool effect, but let's make it even cooler. So if we go to the animation loop function, we can just comment out we can just delete our ctx dot clear rect line, and then now perfect. We have our effect done, and it's like just looking good. Now let's play around with some values. So this is our finished product. It's perfect. When you put your mouse down, it'll draw, and when your mouse is up, it'll stop drawing. But we can play around with the values. If we change white to red, look, we have this. If we change this to yellow, we have this fiery effect. We can play around with as many values as we want, but since this is a frozen spike generator tutorial, we'll just keep it as the colors I put. You can change it by yourself and see what you can come up with, and of course you can use HSL values and hue variables to create a rainbow effect, but I'm gonna stick with the frozen spike tutorial. We can also change the size of the spike by saying this size will go to 0 much faster. So look, it'll create this, which is still looking good, but I preferred the old one. There is a small bug that when you decrease it by 0.2, it'll stop and freeze because it'll go below 0. We can decrease it by 1 and make the spikes super small, or we can decrease it by, I don't know, 0.05. Let's see what, and it freezes, so it goes below 0. But I like the 0.25. It actually looks great. We can also play around with this. We can say this dx times 2, and this dy times 2, and this will make the spikes super big. Personally, I don't think that is, well, I think it's like eh. We can also change it to divided by 2 to get this small spikes. Basically, the smaller the size, the or the more it decrements, the smaller the spikes will be. We can also play around with the amount of particles generated. For example, one particle will be like that, not that good. 5 particles generated will be like this. I prefer 10. 50 particles might lag your computer if your computer's not strong. I'm just gonna show you 100 particles, but I do not like it. So I'm gonna stick with good old 10. Then let's see what else we can play around with. We can change the size of the particles of the spikes, and we can go random number from 5 to 15. Maybe you have to. There we go. See? Perfect. Well, not perfect. I prefer from 5 to 10. We can also change the values of this, like instead of 4 minus 2, we can say 5 minus 2.5 to create a random number from minus 2.5 to 2.5, and the spikes generate faster but also grow longer. I'm going to stick with 4 minus 2. We can also make them generate super slow, like 2 minus 1. Yeah, that makes them smaller because the size decreases faster than the spikes can grow. We can also play around with where it generates. Like we can generate 50 particles to the 50 particles to the right and 50 particles below the mouse. We we can change it to 5, so that's a bit closer. We can change it to like super far. Let's go 100. Personally, I'm just gonna keep it to exactly where the mouse is. It's pretty cool. Um, let's experiment a bit. So let's save the thing, and then translate it to this dot x, this dot y, and then rotate it. Let's see, rotate mass dot pi times 360 slash. Okay, so uh oh no, wait, slash 360. So we'll say it'll rotate by 5 radians, and then we can restore it. Oops, not reset, transform. That's interesting. Maybe if we rotate by 1 radiant. Oh, of course. Let's say this dot angle is random number from 0 to 360, and then we can increase the angle by 1. And then we can rotate it like that, but it's a very weird effect, so I'm going to delete all of this code because it makes it a much weirder effect. Oh, wait. No, I think I understand what went wrong there. We have to change this to 0 and 0 because it's already translating and we don't want it to overlap. Well, go overboard. So, this is very normal. This is not supposed to be normal. Way too normal. What if we say like increases by 10? It doesn't seem to change much, but I'm sure it's rotating. So there we go. Let's delete this code. Well, you can experiment all you want. What if we go like divided by 50. Or wait, this could translate to 0, 0. We'll change that back to 360, and then we can say this the x here. That should be the same thing, right? If this changes, that'll be very interesting. Very interesting. Let's revert it back to what it was and put this as 360. Huh. Super interesting. Well, as you can see, we can do a lot with some simple coding, and I hope you learned something from this tutorial. So this is Dark Shadow signing off. Have a great day, and don't forget to keep